Okay, chapter 4 will be under CL2. We now look at impulse. We now look at impulse and momentum. Previously, you learned about work. You learned about power. Now we look into impulse and momentum. So we start with F equal to ma again. A equal to dv dt. So F equal to ma equal to m dv dt. So if you move your dt to the left-hand side, you integrate F dt equal to integrate m dv. So you pull your F out, F multiplied by T, you get impulse. M maintain, integrate dv, here is V2 minus V1. So mv is momentum. So basically, this is called principle of impulse and momentum. Okay, so this is called principle of linear impulse and momentum. This side is impulse, this side is momentum. Okay, but in the solution, you will see me moving this mv to the left-hand side. Means in general, we want to see what happened before equal to what after. Okay. Don't confuse this one with the work and energy. Yeah? This is impulse and momentum. Okay, the equation makes sense to you? Okay. So this is called linear impulse and momentum. So as long as you need to find velocity in a quick way, you are given force, you're given time, you can find the final velocity in using this equation. Okay. You can solve using F equal to ma also, but if the question forces you to use principle of linear impulse, you need to use this form. You write sum of integration F dt equal to mv2 minus v1. Why there's integrate of t? Because your force sometimes is in t form. Means your force will be 3t plus something. You're integrating the force in t term. Okay, means your force is changing. When your force is changing, acceleration not constant. Acceleration not constant, you cannot use 3 Newton law, 3 Newton equation. So we will use capital L to represent momentum in the following chapter or in the following slides. Okay. So impulse, linear impulse, when you have changing forces, you will see a curve shape, something like this. So you integrate. This one you don't need to copy lah. Just for info, if you have a constant force, then you will get a constant F multiplied by the change of time, the area under the graph. So you pull your F out. If F is a constant, then you're actually integrating the T. So F multiply T, you get area under the graph. But this one, because your F is changing with time, you have a parabolic shape. Then you integrate area under the graph and under the curve. Okay. So this is for convenience of analyze. Means we look at what happened before the incidents equal to what after the incidents. So momentum plus impulse will equal to the end result of momentum. Or you can write at the top form also. No problem. No problem. Okay. So we can illustrate with a diagram. So let's say mv1, you know that m is a scalar. M don't have any direction, but velocity have direction. Velocity is a vector. Vector have magnitude and direction. For example, your v1 is in this direction. Plus f dt. F is a vector. Vector multiplied by time, you get another vector. This is called impulse diagram. So this is momentum diagram, but because it's V1, so this is initial momentum diagram. Middle one is F multiplied T is an impulse, so it's an impulse diagram. MV2 is final momentum diagram. Okay, so for this chapter 4, you require to draw this diagram in your solution. Okay, you draw this one and you write this equation, and then you fit in any information you have in the question. So you can solve if it's a 3D problems by splitting them into X, Y, and Z. Okay, you can split this one, split them by solving in X, Y, Z direction. Meaning what? If you have more than 2 unknown, you have 3 unknown, then you use X, Y, Z equation. You have 2 unknown, then you use X direction, Y direction, solve 2 unknown. You have only 1 unknown, then you use the main one. Okay. So this one is, we'll revisit this one during after we look at rigid body. Now we are now still at particles chapter. After this one, we'll look at rigid body. You'll see this one again later. This one is like small things. You sum up as a one body. You just write F equal to ma. You're still arriving at the same equation. Okay, mv1 plus impulse ft f integrate t plus mv2 is the same. Huh? You see this one in maybe chapter 5, chapter 6 or chapter 7. Okay, in chapter 7, we'll change this equation by focusing on the center of mass. So when you look at rigid body, you're more interested in the center of mass or centroid. What happened to the centroid? Velocity from the centroid. Velocity from the centroid. So from this chapter 4, it's good you start practicing looking object from the center of mass or center of centroid. Okay. So let's look at this one. This question, it can be question 1, chapter 1 question, chapter 2 question. It can even develop into principle of work and energy. Right. So you have a 100-kilogram crane original at rest at smooth surface where pull at 200 Newton. If the towing force is given, acting angle is given, apply for 10 seconds. Now, if you have this time forces, it means it could be chapter 4 question with the impulse, because impulse link with the force and time, mass and velocity. So it gives you final velocity and normal force, which the surface exerted on the crane during this time interval. Okay. This one, why there's no friction coefficient? It tell you on the smooth horizontal surface. So friction 0. It's a normal force. Okay, so can you draw the diagram, free body diagram for this one? It's easy, right? You draw the external force, then you draw the centroid, put in the center. There's a W pointing from the center to the pointing down. Then there's a contact normal force pointing towards the body. Original at rest, they tell you the velocity after 10 seconds. So we try to solve using chapter 4 equation with its principle of linear impulse and momentum. So you write a free body diagram. I think you have no issue on that. Okay. Now, because of this 200 Newton at 45 degree, remember to split into X and Y. Every time split this 200 into X and Y so that you solve your equation in X direction and Y direction. Because, okay. Then you know that when you pull 200 Newton to the right, you know that your velocity moving to the right. This is a combination of kinematics diagram already. You start to put in velocity together with free body diagram. So once you have the free body diagram, you write equation of a principle of linear impulse and momentum. You write mv1 plus sum integration f dt equal to mv2. You write that one. Then you split into x and y direction. You copy the equation again in x direction, copy the equation again in y direction. The rest is substitution. You have the mass 100 kilogram. Velocity you don't know. F, this F is the external force. Means all these force in x direction will have impulse. As long as there is a force, there is an impulse. So this one only have one direction in x direction. Which is 200, what sine or cos? Cos, 200 cos 45 for 10 seconds. So just put 0 to 10. T1 you represent 0. T2 you write 10 here. M 100. V2x you don't know. Okay, V2x you don't know. But V1 you know. Original at rest. So V1 0. You just draw an arrow. Draw an arrow, then you write 0. Okay. So remember to give direction. Remember to give direction, in this case, to the right positive in x direction. So Vx10, force 200 cos 45, 10 second. M, so you only have one Vx number 2. You can do the same for y. Then you have Vx, Vy2. You have two vector, x and y. You find resultant, find the angle. Okay. Y, you copy the same, but what write in the y form or y direction. Substitute again. Vy1 also 0 because starting from rest. Fy is 200 sine 45, 10 second. Vy2 you don't know. You can only have one unknown. Press calculator, you find your V. Okay, so for Vy you have normal force, you have W force, you have 200 force. So principle of principle of linear impulse and momentum, as long as you have force inside your free body diagram, it will generate impulse. If got friction, then friction generate impulse. So I need to highlight this one. As long as there is a force, it will generate impulse. In this case, y direction, NC, W, and 200 sine 45. Each one multiply 10 second, 10 second, 10 second. Then here, Vy2, Vy2, Y0. What is impulse? Impulse is Y multiplied time in Y direction. This is NC Y direction, W also Y direction. This one split out, go up positive, also Y direction. Why V0? Why Vy2 0? Why? Because the object do not move up. It do not tell you the object fly off. So the velocity always, in this case, always follow the surface X only. Okay, so in this case, your Vy2 is 0. Some of you stop here. You don't know how to proceed because you cannot find Vy2. Vy2 do not fly off, so 0. Once you find NC, you find already. So X, in this case, Vx2 in X direction, you will pull along the surface. Okay. You can solve using chapter 3 or chapter 2 question and chapter 1 question. F equal to ma, and you use V equal to Vo plus At because acceleration constant, because your force constant. You can arrive at the same answer also. Okay, but this is under using principle of linear impulse and momentum. Okay, now example 1 is too easy, so we go to number 2 with the angle. Same, but now you're given V1 is 1 meter per second, and you're pulling down from a angle. So you're given 25 kilogram crane with a magnitude of P equal to 100 T. So in this case, your force changing. When force changing, your acceleration will change, so you cannot use the 3 Newton motion equation. Determine the crane velocity 2 seconds after P being applied. The initial velocity is 1 down the plane, and the coefficient kinetic friction is given, mu k 0.3. So important here is to determine where is your positive direction. I will highly recommend start from chapter 4, you follow the motion. If the motion go down positive, you give positive go down. If you follow the object, where does it go? So that you get positive in your solution. You don't need to always convert to negative or positive. So if you follow the motion, it will give you lots of convenience in your calculation. Traditional way, so can. It will give you negative value in your calculation. So do you know how to draw free body diagram or not? How many force on this object? P, external force. W go down, normal, and friction. So on the free body diagram, weight is 1, normal force is number 2, friction number 3. So the total got 4 forces. Total got 4 forces. So 4 forces generate 4 impulse. Depend on the direction. Depend on the direction. Some, if it's yeah. Okay, free body diagram. I don't need to explain much because you're the expert in this one. Only I need to highlight direction of friction always opposite of your motion. Okay, some of you might give the wrong direction for your friction. As you go more and more exercise, you might miss out this one, friction. Okay. Yeah. Then there's a 30-degree between the W and the surface 90 axis. Okay, so once you have that one, you write the principle, linear principle and momentum. You have the M. When it comes to test, just be careful on the mass. Sometimes we give you megagram. You need to convert into kilogram. Sometimes I give you in ton. 1 ton equal to 1,000 kilogram. Okay, so velocity go down. So in my case, I write mv1 plus some integration f dt equal to mv2. Then I split into x and y. Because I have NC, I have friction. I have two unknown. Two unknown, if I only use one equation, cannot solve. So I split into x and y. I got two equations. I can solve. Okay, the problem here is where is the positive direction? So in this case, I follow the motion, go down positive. You can use the normal, go to the right, positive, go up positive, but you need to convert everything into sine cos. It's very troublesome. Huh? Follow the motion, follow the surface. Then it will give you better solution. Okay, mvx, m is given, v you don't v is given. Initial velocity is 1, but in x direction, plus integration of forces dt. Here in x direction, you have p. Sorry, I think this one 2 seconds. So 2 seconds is t, but yeah, you put in 100 t here, 100 t, then 0 to 1, you get 200. Then friction in x direction give you impulse, but in opposite direction. W also give you two direction, one going down, one go to the left. Okay, then you substitute the value. Okay, so mv1 x plus p dt minus f friction, because friction go opposite of your x direction, plus w sine 30, because if you split your w, you have going this way and going down. Looking at x direction only, you don't know the time. You just in this case, I didn't put in the time yet. I just derive the general equation. So mvx integrate 0 to 2 p dt minus ft plus w sine 30 t equal to mv2. Then only I substitute value, or I further develop the equation. Don't substitute. Don't too fast to substitute value inside there. Write equation first. So then you get all this answer. So there's only one unknown. If you there are two unknown, NC you don't know, V2X you don't know. So this one you simplify, then you wait for the second equation, which is y direction. Okay, you arrive at one equation like this: 25 plus something minus something plus equal to 25 Vx2. Okay. So in y direction, we just straight away. Of course, you can use this in y direction, but this one I just show you. I straight away use f equal to ma in y direction. So f equal to ma because the object do not float up. So your acceleration 0. Here don't mix with statics. Here don't mix with statics. Static is equilibrium, but this one f equal to ma 0 because the object do not fly up. Your acceleration in y direction 0. NC equal to 30 cos 30 equals 0. You get your NC. You can use this equation if you want by changing the y. You can still get what is NC. So once you substitute inside the first equation just now, you get your Vx2 equal to 13.7 meter per second. Okay, once you get your V2, this one is solved by X also. This is show you that how to get the V by using F equal to MA, where you need this one for your test one question. Okay. Okay. This is using F equal to MA, but you can try using the linear impulse and momentum equation in Y direction. Then you substitute the second one into 1, or solving simultaneous equation, 1 minus 2 or 2 minus 1, and so on. Okay, important you understand how we solve. The rest later you get the slides from in the canvas. Okay, example 2. Okay, example 3. Pulley system again. You see there are two objects, 3 kilogram and 5 kilogram. Even you drop 5 kilogram, you know that object A will go up. So you have 3 kilogram, 5 kilogram. If the system released from rest, determine the velocity of block B in 6 seconds. This one you can solve F equal to MA equation plus the pulley system equation, LT plus equal so and so. However, this question, because it's chapter 4, you need to solve using linear impulse and momentum. Okay. So you draw free body diagram of pulley D. So pulley D got 2 tension, 2 cable on the top, 1 cable at below. So you have 2 TB over there. Okay. Why TB? Because this rope was tied to the mass B. Of course, you can write D also TD, but TD equal to TB. It's the same. Then TA, this one is equal to 2 TB. This is to remind yourself that this one actually half of this cable. Then you draw object A, W go down, and there's one tension cable go up, which is a TA. So TA equal to 2 TB. The purpose of drawing this one is to find the tension of B. Okay, if you draw object B, W go down, TB go up. So these are the free body diagram expected when you see a pulley system. Okay, so this one also expected in the coming test 1, question 1 question. You are expected to draw free body diagram like this. Okay, so all the pulley system have positive datum direction. SA go down positive, SB go down positive. So velocity of A go down positive. The positive direction for VB is go down positive. This again, if you see green color with the velocity, is a combination of free body diagram and kinematic diagram. So you start to write the equation for pulley. Total length equal to what plus what. Here got 2 SA plus 1 SB. Then from here you time integrate of total length, you get 0. You time integrate SB, you get VB. This one, you get velocity of A. Okay. At the end, this is what we want to see. VA equal to VB. But for your test 1, question 1, please continue to time differentiate V. You need to arrive at acceleration for your coming test 1, question 1 question. From here, time differentiate one more time, velocity become acceleration. Okay, so this one we only need to stop at velocity. But for your coming test one, you need to determine the acceleration. You write principle of impulse and momentum. You write for block A. Block A velocity go down positive. W point down, going up got 2 TB. You write go down positive. MVA plus sum of force dt plus MB2, MVA2. So in this case, there's only either go up or go down. So you don't need to go give X and Y. In this case, go down positive. So VA release from rest. So VA 0. You can draw an arrow and write 0. FY, you have two forces here in Y direction, 2 TB and W. Go up is negative because you go down positive because of the datum direction. Okay, minus 2 TB. Time is given 6 seconds. And force, this one is W. M is 3 kilogram. G is 9.81, 6 seconds. And VA2. So here you have two unknown. You go for B, this is A, then you go to B. Just beside the diagram, you write linear equation again. MVB plus sum of F dt, MV2. Release from rest, so VB 0. TB you don't know, you continue to write TB. And this one again, go down positive. That's why your TB is negative in this way. TB negative, go down W positive, mg multiply 6 seconds, 5 VB2. So we have two equations. TB equal to something VB, you can solve simultaneous equation. Okay, first equation, second equation. You have the same TB here. You can either rearrange equation number 2 in TB equal to something, substitute back here. Okay, then you have VA equal to VB from the pulley system equation. You can either substitute here or here, then you solve simultaneous. There are lots of ways, depend on your preference. Okay, the idea here is solving simultaneous equation. Okay, so when you solve, you get, just for your check, VB equal to 35.8 meter per second, go down. TB is 19.2 Newton. In this case, the question asks you determine velocity of B. In your coming test 1, you need to determine object 1 and object 2 acceleration. Okay. We only have 1 hour, so I think we stop here. Next lecture, we go into conservation.